All right, so let's do one more example where we utilize the law of sine, and then we'll turn our attention to the law of cosine. Okay, so it says here, a surveyor makes the measurements shown to determine the length of the bridge to be built across the lake from the north picnic area to the south picnic area. So we want to go from the north picnic area to the south picnic area. This is going to be a bridge. Okay, so this here tells me we're looking for side C. That's what we're trying to find. Find the length of that bridge. Okay, so if it helps you, you can go ahead and do big A, big B, big C, little a, little b, little c. And we know that angle C is 60 degrees. This is side B, so B is 150, A is 71 degrees. This here is what we want to find. Okay, well, we know these two angles here, so we can find angle B because we know they all have to add to 180. So angle B would be 49 degrees. Okay, and when I add that here, notice I have my side angle pair. Okay, so I can set up a proportion. So I could say B over the sine of big B equals little c over the sine of big C. Okay, so now it's plugging it in. So 150 over the sine of 49 degrees equals c over the sine of 60 degrees. Okay, I cross multiply, so c times sine 49 degrees equals 150 times sine 60 degrees. Okay, I want to get c by itself, so divide both sides by sine of 49 degrees. And when I do that, I get, those go away, so I get c equals 150 sine of 60 over sine of 49 degrees. And when I put all this into my calculator, I get c is roughly 172.1, and we are in meters. All right, now let's use, or let's learn the law of cosines, okay? So once again, we use the law of cosines, use with non-right triangles. Okay, and once again, sometimes it works with right triangles, sometimes it does not. So we can't use it with right triangles because at least at this point we don't know if it's going to work or not. Okay, and we use law of sine, or law of cosine, sorry, when we do not have an angle side pair. Okay, law of cosines when we don't have an angle side pair. Because remember, when we have an angle side pair, we use law of sines. All right, so let's look at this example here. Okay, it says solve the triangle round to the nearest tenth. So I'm going to find angle A, angle B, angle C, side A, side B, side C. All right, so I know angle B is 34 degrees. I know side A is 11, and then side B, I don't know. Side C is 14. Okay, so notice, I don't have an angle and a side pair anywhere. Okay, and because I have one of each, it doesn't matter which one I want to go with. I can find either one. So I'm just going to go, let's find little b first. Okay, so to find little b, I'm going to go here and look at these. Now, guys, these are the same formula, just written with different variables. But think of this triangle here, okay? If I were to relabel this A, B, and C, but have all the same angle measures and all the side lengths, I can reorder these, C, A, B, and it doesn't matter. It doesn't change anything. So these are just in different orders. It's the same equation. Okay, so I want to solve for B first. little b. So I use the equation b squared equals a squared plus c squared minus 2ac times cosine of big B. Okay, and from here it's just plugging stuff in. So b squared I don't know. So a squared is 11 squared. C squared is 14 squared minus 2 times a is 11, c is 14 times the cosine of b, which is 34. Okay, and you can realistically put this whole thing into your calculator. And when I put all that into my calculator, I get b squared is roughly 61.65-ish percent. 61.65 rounded. Okay, so that's b squared. So to get b by itself, I want to square root both sides. And I get b is roughly 7.85. Okay, now notice I have my Ingleside pair. Okay, so I can now revert back to law of cosine. Okay, so I can say that a over sine of a is going to equal my b over my sine of b. And then it's a matter of plugging in. So little a is 11 over sine of a, I don't know, equals my b, which is 7.85, over my sine of 34. Okay, and if I cross multiply, I get 11 times sine of 34 equals 7.85 sine of a. Okay, then I want to divide both sides by 7.85, get sine of a by itself. I get 11 times sine 34 degrees over 7.85 equals the sine of a. So I know the value of the sine of a. I want to find my angle A, so that would mean I'd use sine inverse, and when I do the inverse, these two would flop places. Okay, so sine inverse of 11 times sine of 34 degrees over 7.85 equals A, and then all I have to do is plug this into my calculator, and when I do, I get A is roughly 51.6 degrees. Okay, now after I have two angles, my third angle is very easy to find because I know they all have to add up to 180, so this is 94.4 degrees. I have now solved my triangle. All right, go ahead and try this one on your own. This is very similar to the one we just did, and then we'll go over it. All right, so when you do this, you first have to use the law of cosine because you don't have an Ingleside pair, and this is not a right triangle. So I solved for little b, and so b squared equals a squared plus c squared minus 2ac cosine of b. And then I just plugged in for my a, plugged in for my b, once again a and b, and here's angle b. Okay, I can put all of this here into my calculator just like it's shown, and I'd get b squared equals this number, and then of course to undo a square you square root it, and you get b is roughly 61.14. Okay, and then after you get that, now you have an Ingleside pair. Okay, so now you can resort to using law of sines, which I did, and I solved for angle A first. It doesn't really matter which one you do. And I got angle A is roughly 47.4 degrees. Okay, and then after you have two angles, the third one is fairly simple to follow because you know these all three have to add up to 180, so you have to do very little math to get C.